All right, so here we're talking about Hess's law and enthalpy formation. And so the sum of the standard enthalpies of formation of all the products plus the sum of the negatives of the standard enthalpies of formation of the reactants. If you add all that up, you can find the standard enthalpy for the reaction. And so let me show you what this messed up equation here, what it should look like as it's written out. And so you can see here. So the standard enthalpy of the reaction is going to be the sum of the coefficients, okay, of the products times its standard enthalpy of formation of the products minus the summation of the coefficients times standard enthalpy for the reactants. Okay, so we're going to do a calculation where we're using this equation to figure out the standard enthalpy for the reaction. All right, so we're trying to find the standard change in the enthalpy for this reaction. We're having to look up the standard enthalpy formation values in Appendix G. So if I take a look at Appendix G from my textbook here, here are my standard enthalpy formations for different substances. So I have to look up what's in the chemical reaction. So here, here's my overall given chemical reaction. I have nitrogen dioxide reacting with water, yield nitric acid and nitrogen monoxide. So here is my equation for finding the standard enthalpy change for my reaction. And that's going to be equal to the summation of the coefficients times the change in the standard enthalpy of formation for the products minus the sum of the coefficients times the standard enthalpy change of formation for the reactants. And so here I've shown you pretty much what it means in general terms. So it's going to be the summation of the products. So the products here are nitric acid and nitrogen monoxide. And so here there's 2 moles of nitric acid, so 2 times the standard formation for nitric acid plus 1, because NO has a coefficient of 1, times the standard enthalpy formation of NO, so it's products, minus summation of NO2, and there's 3 moles there, so 3 times the standard formation, change in formation of enthalpy for NO2, plus 1 mole of H2O liquid, so 1 times the standard enthalpy of formation for water liquid. Now, when you're looking up these values, you have to make sure, again, you're looking at the state of matter here, because there are different values for liquid water compared to water as gas and so on. So I just wanted to show you where I got these numbers from. So we'll look at the first one here. Here I'm just plugging in my standard enthalpy of formation values. I have to look this up on in Appendix G. And so HNO3, if I look that up in my Appendix G here, it's alphabetical for the most part. So let's see, HNO3. So HNO3 has a standard enthalpy formation value of negative 206.64. So negative 206.64. Okay, then I look it up again for NO, nitrogen monoxide. And so NO, let me look to see what the state of matter is. In that case, it's probably a gas. NO is a gas. Okay, so NO gas here. So again, I look up that value in Appendix G. Let's see, NO gas is 90.25. Okay, so again, that's where I'm getting that number from, 90.25. And that's for my standard enthalpy of formation for nitrogen monoxide. Okay, so I'm plugging those numbers in there. Okay, and same process for NO2. I looked that up. Of course, NO2 is a gas as well, and so I would look it up for the gas, NO2, and I get 33.2, and then I looked it up for liquid water, and it's negative 285.83. Alright, so now I have to do the math here. So 2 times the negative 206.64, that's negative 413.28. 1 times 90.25, that's 90.25. Minus, so products, all these are products, minus reactants. So my reactants are 3 times 33.2, and I get 99.6. And then 1 times negative 285.83, and so that's negative 285.83. Okay, and then I'm going to, here I'm going to add up my products and my reactants. So my products end up being negative 323.03 minus, so products minus reactants, so my reactants added up together equal a negative 186.23. So here when I take the difference, this number becomes positive, this number stays negative, and so I end up with a negative 136.80 kilojoules. Okay, and so that is example 5.50.